All right, let's get rolling. It's top of the hour. We want to make sure that we're being respectful of everyone's time. So welcome. Thank you very much, everyone, for joining us today for our Catchpoint Internet Stack Map demonstration. We're going to spend some time talking about one of the coolest and most revolutionary new products that I've seen Catchpoint bring to market. My name is Mark Towler. I'm a product marketing director here at Catchpoint. I am joined today by Brandon Delap, who is one of our senior sales engineers, and he's going to be giving a demonstration of Catchpoint's Internet Stack Map, as well as Tony Forelli, who is our VP of Operations, who's been using Internet Stack Map for quite some time, and he'll be happy to provide some context on not only how it works in the real world, but how it's changed the way he does things here for the better. For a little bit of housekeeping, we will answer questions at the end of this session. If you do have questions, feel free to put them into the Q&A tab that is there on your screens, and we will get to them. If we run out of time, which I'm not expecting, but should that happen, we will get back to you with all of these questions at the end of the session or over the next day or two. And with that said, let's jump right on in. So one of the challenges before all of us is the fact that the internet is huge, it is complex, and it is very, very fragile. We used to talk about how the internet is now your new network, but really it's now your new application infrastructure as well. And what we mean by that is that no matter what you're doing, you no longer basically have your own data center with your own servers and your own application software running on those servers. Everything, all your apps, all your microservices, all the APIs, they're distributed out in multiple different clouds or multiple different places. This has a lot of benefits, obviously, but it does make everything a lot riskier because everything is a lot more complex and a lot more fragile. So what does that mean when it comes to maintaining resilience for your key applications? And by key applications, I'm talking about the stuff that makes everyone go, oh my God, when they stop working or when there's slowness. You all know what they are. Everyone's are different. They are the items that will cost you thousands or tens of thousands of dollars per minute if they slow down or stop moving. And again, they're just as dependent as any other application on that complex, fragile internet, and they also have dozens, if not hundreds, of dependencies, which is a challenge because you can't see into about 80% of all of those other elements. They're outside of your control. They're still your responsibility, but they're outside of your control because you just don't have the visibility to the internet stack that you used to have when your internet stack was your server rim. And if you're going to keep an eye on all of those third parties' status pages to see if they've announced when they're down, or keep an eye on social media so the users will report when things go down, that's just not an adequate solution. Your critical apps do require real-time data. Again, if you're looking at thousands of dollars per minute, you can't wait to see whether or not a dozen users in some region have decided maybe it works, maybe it doesn't, and you can't trust that crowdsourced data. If the vendor or third party actually bothers to post an outage report, and they often don't, that's going to be hours later, and that's just not an option. You've got to be proactive. And when something does happen, you can't rely on calling a war room. This is something that's incredibly disruptive to your business. It's incredibly expensive. You've got a lot of people with high dollar costs per minute who are getting involved, and the first thing they're going to start doing is finger pointing. Whose fault is it? Who can avoid responsibility? And none of this is fixing anything or getting to the root cause of the incident. So grim picture, but wouldn't it be nice if you could look at the entire internet stack for one particular application? Just imagine if you, for example, had one front-end application and you've got users at the bottom here who are accessing your network. How do they get through the entire complicated internet stack? Wouldn't it be nice to know that? Well, that is what Catchpoint has brought you with Internet Stack Map. We've provided a way to take a look at one particular application and trace exactly how it uses every single element all the way through the stack, right through to the end user, and that's global. This is something that's going to allow you to find performance issues before they impact your business. And notice I use the term performance. Outages are one thing. These days, slow is the new down. So even if your system's up and running, if it's taking a minute to respond, that's not adequate. You're losing customers left, right, and center. But Catchpoint's Internet Stack Map is going to give you a live view of the health and the status of your digital service and of every single component connected to it. And this is great because it's real time. It does this automatically. It makes it easy to simply look at this board and identify root causes. You can actually go back in time. There's that timeline on the top. If you're a Catchpoint user, you're familiar with that. You can just go back to the left and track the history. And every single one of these components you see here is something you can drill down to. In the past, you've maybe had to look at individual synthetic test results or RUM data. This looks at it the other way. I can see from my application's perspective what's wrong. I can click on it and I can drill down until I get to those actual individual test results. All right. This is tremendously valuable. It leverages something called Internet Sonar, which is another product we've had around for a while, and we'll explain how that works again in a second. But this is really what's going to be making a big change and making it a lot easier for you to take one look and go, hey, what's wrong and how do I fix it? There are a number of benefits that StackMap brings to you. And again, we're going to get to a demonstration in just a minute, but I just wanted to highlight the value of it. You're basically eliminating, if not completely, but drastically reducing your mean time to identification and your mean time to resolution, which is going to save you time and money. As I mentioned, you're looking at your entire internet stack, but from the perspective of your applications, not necessarily from your users. It's very simple. It's very intuitive. One thing that we think is kind of emphasized is the fact that this is very simple. That map we were just looking at is very simple. Anyone can look at that and go, oh, that's red. That's probably a problem. You can show this to executives who don't necessarily have a good understanding of how network operations works, and they're going to understand it. You can show it to the guy you just hired out of engineering school or the summer intern, and they're going to understand it as well. What it's going to do is help you improve your internet resilience. It's going to protect your revenue, and it's going to protect your reputation of your organization. It's really the value of IPM all in one dashboard. How do we do this? And I'm talking a big game, but can anyone else do this? Well, not really. There are a couple things that make this unique that only Catchpoint can do. And one of them is our global observability network. We have the largest one in the world. If you look closely, you'll see a date at the very bottom of this slide. That's because these numbers keep changing. We are constantly adding new nodes all over the world. No one has anywhere close to this kind of observability network. And this is what allows us to be global, to say, okay, everything looks great here in New York, but there's someone in Tokyo who can't connect. There's someone in Dubai who's having a problem. It's very slow for people in Sydney. This is the sort of thing that we can provide information for. The other piece that only Catchpoint can provide is Internet Sonar. I mentioned it earlier. Internet Sonar is a separate product. I'm not going to go into it in tremendous detail in terms of what it can do. We've got content on our website that goes into great detail, but basically it is a tool that will continually test all of those nodes I just showed you. And that's, again, something no one else can do. We're talking millions of tests, which results in billions of data points. And we've got an AI correlation engine that eliminates all the false positives, puts something together and gives you a nice, neat map saying, here is what's out in the entire world. And again, this is another thing that's at a glance information. It answers this question, is there something wrong with my system or is it someone else? All right, and Internet Stack Map uses that sonar data to generate those real-time dependency maps we just saw, and it answers the question, what's wrong with my application? So together, you're able to determine, hey, is this my problem? Is it someone else's? And if it's my problem, where exactly is the problem? Again, something only Catchpoint can provide at this point. And with that, I'm going to wrap things up because no one cares about what I'm saying. I want to hand things over to Brandon, who is also going to have some chiming in from Tony as we go through, and he's going to give you a full overview of exactly what we do with StackMap, how it works, how to build stack maps, and get into all the juicy details. Brandon, you ready to take over?
Yes, I am. Thank you very much, Mark. Let me go ahead and stop my share and then share my screen. All right, excellent. So where I want to go through here with the remaining time is go ahead and walk through a couple of use cases for a demo app that we have. It's a cinema app. It's essentially replicating a movie ticket booking app. It makes for a great demo, of course. And then from there, I'll go ahead and touch on how this was made, and as Mark mentioned, how we leverage your existing synthetic as well as the sonar data to auto-discover some services that are powering your application, as well as filling in the metrics and the availability data with this stack map. So let's dive right into it. Perfect. So what you're looking at here is a stack map that I created, again, for that cinema app. What we're doing is automatically breaking down each component of your application into what we call a layer. Now, a layer can be a number of things. It could be your DNS layer, so your DNS providers, whether it's single or multi-provider, your front-end layer, your third party, so essentially those additional third-party tags or pixels or API microservices that are outside of your control, but are important to highlight on a stack map like this. And then we can also go into back-end or origin layers and add your databases, your cloud infrastructure, and different microservices as well. So with that being said, what I want to do is walk through the first use case here. Now, the first use case would be, what if one of these third-party providers outside of my control is currently experiencing an incident? Now, what we call an incident could be a DNS connection, response, timeout, or failures. So essentially, that's us telling you from the sonar data that we're capturing, are there any incidents, any events going on for that specific provider outside of, obviously, your own synthetic testing? Now, we highlight incidents with orange. So you can go ahead and hover over this specific provider or service, and you can see that it is currently experiencing an incident. Now, if you click into the incident, what that'll do is take you over into another visualization. Now, this visualization is the Internet Sonar map. And what this does is highlight, obviously, those services and whether or not there is a current failure for those services. So you can see here for generic cloud, we're highlighting that this is ongoing, and we're seeing a DNS error from 61 cities. If you go ahead and drill into that incident, you can see what those cities are, what's the percentage of downtime during that time frame, and more importantly, what domain is currently being impacted by that specific incident. If I jump back over into the stack map here, now I want to walk through another use case where it may be impacting a service that you actually control. So if we go ahead and follow the stack map, that essentially guides you down to where those issues are being introduced, you can see that it ends up here at my database service or in my backend. You can go ahead and click into that specific service and layer. We'll show you the synthetic service time as well as the downtime for that specific service. And then you can click into the additional data. And what this will highlight are if you have any alerts tied to this specific server. And in this case, we do. You can see that we're experiencing test failures during the current time frame. Then you can click into the errors tab, which will actually bring out those individual test runs for you. Instead of having to do multiple clicks into, a smartboard, into a record, and then drill into the waterfall, you can go ahead and bubble that data up here. You can see what test is being impacted, what's the time, where are these issues being experienced, what is that specific URL, and then most importantly, what is that error code that your application is telling you. So in this case, you can see that we are getting several unauthorized failures as well as a bad gateway for this specific service. Now, you can then follow up and click into a individual waterfall. So let's click into one of those that experienced an unauthorized failure. You can see here the unauthorized message from the server. And more importantly, you can see, well, what step of that transaction are we seeing the issue? And in this case, it's on step 2, where we're trying to log in to the application. And we see that 401 unauthorized. Now, because we have tracing enabled for this application as well, you can go ahead and see the trace ID there, or better yet, click into the view trace. And what the view trace will do is take you over into a trace map here for that specific service. So similar to the stack map, you can then go ahead and follow the path that this specific trace initiated and the different services that were called, the services that were impacted by the failure. And at the end here, end of the trace, you can go ahead and see from the MySQL perspective, well, what was the error message at that point in time? And in this case, we were seeing an unauthorized failure because the database was not responding in time there for this specific event. Let me go ahead and jump back out into the stack map here and kind of click into how you can go ahead and create one of these. So as I mentioned, right, the first and foremost thing is we're leveraging your synthetic data. And these could be tests that you already have configured, or if you know that you have a specific way to test one of these individual services, you can go ahead and create a specific test for that. Now, when you have those tests created, you can leverage the auto discovery portion of the internet stack map, where you tell it, go ahead and select some tests that you essentially want to add to this specific stack map. In this case, I want to add, my user journey for this specific cinema app. Select that test. And what we will do using that auto discovery from the Sonar data is automatically pick out services that are behind this application. And because it's a multi-step transaction, that can be multiple different providers, even down to the individual regions that we're seeing this application being served from. So when you see that, you can go ahead and then drag it over into one of your service layers. And now that individual service will be available to you in your stack map. So this is something that obviously, as you go on, go ahead and it could be amended if there are any changes to your infrastructure and you need to add some additional critical services to your stack map.
Cool. I mean, the only other thing I want to highlight here is, applications are becoming more and more complex, right? We've already talked about that. Different teams own different microservices. The nice thing about Stack Map, it will help guide if you have a knock or something like that that's getting these things initially, or if the alerts go to specific teams, they'll be able to go in here and see the relationship between their service and other services, right? I think that's one of the powers for us. We have multiple teams. Not everybody has full context on the way the entire application works, right? Usually there's like a handful of people in a company that actually understand that. And what Stack Map does is kind of let you lay it all out on the table. So even somebody that's stepping in for the first time, like you have a new person, or like I said, you have a knock, right? They can actually look at the stack map and they know the relationship between different services. And then, you can document like, well, who actually owns that service? Which on-call group should I be paging because this event is happening? Or they're getting paged, right? Because an alert's coming up here, right? And they can see how they're affecting everything else, right? I think we've all experienced it's slow, right? The generic, hey, it's slow. And you have to figure out what's going on. Stack Map helps you narrow down where that slowness is happening. And like I said, it helped guide the team, right? It's there as kind of an overlay to say, okay, here's how everything fits together. Here's the team that should be called at this point because their service is impacted, or their microservice is impacted for that matter.
That's a good point, Tony. Now, I guess before Stack Map, how was the team, trying to piece together those different components to get on the same page?
Yeah, I know. Like if you use Catchpoint already, right? You can build dashboards, you can build custom dashboards. That's what we've done a lot in the past. But it still doesn't give you that perspective of how this thing fits together with that thing. We do have a knock, right? So we do have a team that's monitoring 24/7, right, to see what's going on. But these people are generalists, right? They don't know exactly all the different services that are involved. So it's really, really important having something like this as a part of their, a screen that they keep up all the time. It gives them a really, really easy way of referencing and saying, oh, I got to call the DBAs because there's a problem happening on one of the backend databases, right? It helps you focus on that really, really quickly.
Excellent. Looks like we have a question here. Does Stack Map dynamically determine slowness? Do you automatically discover the load balancers, edge, ALB, NLB, etc.?
We can actually save those till the end if you don't mind, Brandon.
Okay. Yeah, no worries.
Hate to interrupt your demo, but yes, we will respond to that one, I promise.
Excellent. Perfect. Let me go ahead then, if it makes sense now. I think there is a survey that we want to initiate before we take over or jump over to how Tony and the Catchpoint team is currently leveraging Stack Map today.
Sure, absolutely. In fact, here's one of the questions we've got. I need to open that and share. That should be live. Are we seeing it?
think
No.
I need to stop my share 1 second. All right, now if you want to try it.
There we go. Thanks. We're curious, which of the following are you using? And you can select more than one here. Do you have a network operations center, or NOC, as Tony was referencing, or multiple cloud providers, multiple CDNs, multiple web application firewalls, or botnet protection, or geo for content language in your app? And we're asking because we happen to know that these are some of the things that StackMap seems to be most useful for. I'll give you a minute to go ahead with that.
Yeah, I think we're all in like similar boats here, right? Like, you know, I've been doing operations now for 30 years, and you never trust anybody, right? So if you just have one web, you know, if you just have one cloud provider or one CDN or one WAF provider, you know, you're taking a risk nowadays, right? Because these guys all have major outages. These guys all have issues, right? That are hard to determine what the problem is. And so, like, even if you're doing active passive, which is what we do a lot, you know, so I have one that's always working and then one that's waiting in the wings, ready to go. Like with the, you know, flip of a button, we can cut over to our alternate. I think it's pretty common nowadays, right? To do that. So yeah, so a bunch of people have NOCs. Everybody's using, looks like a lot of people are using multiple cloud providers, multiple CDNs. So yeah, I mean, I think we're all in the same boat, and it becomes a big challenge, right? How do you monitor that? How do you keep all that stuff organized? And then who knows about it, right? Like, and I think, you know, for me, that's one of the key things that StackMap provides is it tells us, um, it tells us what's happening with an individual provider, even if they're not the active provider at that time, right? Which I think is invaluable, and then it makes it easier, right? Because like I said before, a lot of folks, you know, not everybody knows all the components that go into their application, right? It's you know, it's a handful of people that know all the interactions that are there. So having a visual representation of that, I think really helps kind of speed up, you know, speed up the understanding of who do we need to get on the phone, right, to fix this problem, right? Or who do we need to contact on Slack or Teams or whatever, right, to get there to be working on that problem to help fix it. Hopefully you already have mops and stuff in place that like somebody can go in and just it's an auto fix. So like these things could become triggers, right, for auto remediation. But in some cases, like I said, you want somebody that you know, you want a human involved, right? That's gonna pull that trigger, right, when something's really going wrong. So I think we can jump off of the
Yep.
survey now.
Let's go back. If you want to share again, Brandon, I think we can go back to the demo.
Perfect.
So I'm putting up like a really simple example. So this is just our API for our users that use Catchpoint portal. It's not super complex. You know, one of the things we do is we don't trust cloud providers for our core application, right? We want to be independent. We have a lot of cloud providers that use us and they want us to be independent of them. So we maintain traditional infrastructure. You know, so when we set up this stack map, you know, we're still in the early stages of understanding how to use it and how to best leverage it. You know, so these are like, you know, like I said, these are our first attempts about like what we're doing and how we plan on using it. But there's a lot more sophistication that we can do as we go along, right? So really simple representation, you know, we use NS1 for our DNS. We use Fastly for CDN, but we also have an alternate CDN that we can cut to. It's not represented here, but we'll add that in at some point, and we'll actually run active. We already run active tests against it to make sure that, like, if Fastly's having issues and we want to cut away, we can cut away at a moment's notice, right? And having that on the stack map will actually help us in the future, right? So, you know, like I said, still early stages for us. We're just learning. You know, we already have the test out there, and like I said, the nice thing about StackMap, what it does is it brings everything onto one one diagram, so you know the relationships. It's not just like a stream of alerts are going to come in and then somebody has to parse those alerts, right, to understand like, oh, I just got 50 alerts, for portal, being down, or the portal API being down. Okay, where's the problem? What's happening? Stack map, based on layered testing, right, we can actually see what's happening there. And we took a brute force approach at first, but we're going to start to get a little bit more sophisticated, because stack map has some powerful tools that you can actually use to make it simpler, right? So, if you look up top, we do a complex transaction test in the beginning to test the API, right? That flows all the way through, right? Now, the problem with that test is, in the old days, everything below it would be red, right? So if that test fails, everything down below it's red. But what we've slowly done is we started to create custom tests, right, for each layer in this map, right? So if you look at the load balancing layer, right, we actually test to the origin VIP directly, right? Which hopefully everybody does. You trust your CDN, but you don't trust them. You want to make sure that your origin is always good. So we have individual origin tests that happen. So so we know if, the upper layer test, right, the top test that tests everything is bad, but the origin test is good, we know it's got to be like a Fastly problem, right? It's got to be something at that layer. And then we go all the way down the food chain with that, right? So we test individual servers in the API pool. And if you click on that, I actually set up a failed test just so you can kind of see what it looks like. So there's a test that's always going to fail because one of those servers is always failing, right? Now, since it's a pool of servers, I already know that server doesn't exist, so it's not in service. So it's actually not creating a problem, but that's something that I'd want my team to investigate when it's happening, right? Like I'd want to know, hey, one of these servers is failing its health check. We actually run our own enterprise nodes. So if you use Catchpoint, we have that public node network that Mark showed earlier that has a lot of things on it. You can actually run private instances of those enterprise nodes. And so what we tend to do is I'll put an enterprise node on that same IP subnet as where those API boxes live, right? So they can run individual tests to each of those API boxes, right? It could be as simple as pulling the health check, that we use on the load balancer, or it can actually run a transaction on there if we wanted to. And the transaction test actually becomes really important because that will show if that individual API box is actually having latency issues, right? So if it's part of the problem, we would see that. And then we do the same thing when you go all the way down. Sorry, if you want to zoom in a little bit, it's kind of an eyesore. It's kind of hard to read right there. But I mean, you can see we have multiple databases that sit on the backside. One of them SQL, one of them is a custom time series database. And then we also use Redis for caching. We have individual tests, like I said, on enterprise nodes that are on those same segments that test those individual things, right? This way, it's really easy for us to carve out, hey, if there's a problem happening at any of these layers, right? Like it will show up red on our dashboard. And we know that's the team that we need to go get involved, right? To start help troubleshooting the issue. Or the team does it themselves, right? If they have that access. So it becomes this really, really easy way of narrowing down where problems are. So, like I said, so we know who to engage, right? And we know how to go and fix those problems. The nice thing is all these are tests that we already had created. But like I said before, you would get a stream of alerts and somebody would kind of have to piece together what's happening. Now we don't have to do that because the tests are kind of organized for you in this stack map, right? So I think it's really important that as as your teams start to work together, they start to kind of visualize on how all these things interact with each other. These stack maps are going to actually become part of our production readiness review process, right? So we create a PRR doc, right, that kind of outlines the service, outlines how we monitor. But we always, used to use Visio and draw diagrams, really complex diagrams about the way things are laid out. The stack maps actually become those diagrams now, right? Because like I said, that's the way we're visualizing the service. That's the way things are supposed to work. And then the individual teams that manage microservices can actually dig into that, right? I have a line off to the side on DR. That's something that still needs to get fleshed out. We have DR, but we need to draw it out. If it's using multiple cloud providers, I'll go back and say again, enterprise nodes are your friend, right? Like deploy an enterprise node in Google Cloud if you're using Google Cloud. Deploy it in the same region as where your services are, right? Or if it's multiple regions, deploy one in each one of those regions. Because like I said, you can now use those nodes as another data point to tell you how your application is doing from that, or that microservice is doing from that perspective, right? Like it becomes this really, really important kind of layering of monitoring that you have, so you know what's happening, you know where things are, and you know which thing is having the problem at that time, right? And this is so I keep this up. So if you jump to kiosk mode, it's super valuable. I don't think we've shown that yet, but like I keep this up on on the backside of my multiple monitors, right? So one of my monitors has multiple stack maps on it for the different key services that we have, and then these things auto update, right? Every 2 minutes or every minute, whatever you guys want. This way I kind of know what's going on. It becomes a handy dandy reference for me, right? So if I see something happening and we didn't get an alert about it, I can let my team know and say, okay, we need to dig into this. What's happening here, right? And then, the nice thing is every layer can have multiple tests, right? Like you don't just have to have one test for like an individual API box. You can actually have multiple tests that test multiple things. That will all be there, and they'll all show up when there's a problem. Let's see. Let me check my notes real quick. Yeah. So I talked about complex tests before. Like one of the things I just discovered over last week is you can actually take a complex test. So let's say you do, like, in Brandon's example, it's an e-commerce site, logging into it, so you set up a transaction test in Chrome that logs into a site, searches for something, puts it in a shopping cart, purchases it, and logs out again. You can actually pull that transaction apart and just say, look at the DNS query for like an ad or an underlining JavaScript tag that's on that page, and actually have that data be represented on your stack map for that specific service, right? Because like you go to common websites today, they're not just going to like CNN.com. If you go to CNN.com, there's like 30 underlying domains that you're actually hitting, right, as part of that transaction. You can actually map those things out, not have to create 30 different transactions for each one of those. You can actually carve that data. You can actually filter that data out via the stack map and look at the DNS times, look at the transaction times for like a specific component of that transaction. Like for our UI, we redirect to an auth server. An authentication server, right, that we send you to. It's a different pool of servers that does that. We actually do that in our stack map for Portal, where instead of creating a new test just for IO, we can use that filter to already carve out the IO transaction that's happening that's part of a transaction Chrome test, right? So it becomes really, really simple for you to do really complex things, and then filter out to the data that you want to focus on.
Yep, and that's through the service criteria and obviously data association fields here when you're configuring the stack map.
So like one of the other things we're going to start doing on our side is, so we have a ton of backend systems. So you saw that map that Mark put up before. We have 1,000 nodes all over the world. We have a command and control infrastructure that controls, scheduling tests on all those nodes and getting data back from all those nodes. We're going to be building out stack maps for those transactions too, because it's a complex system. That very few people understand how everything fits together. A stack map's going to make it easy for my tier 1 guys to walk in the door, be able to look when an error comes up, be able to look at that stack map, and hopefully focus on getting the right team involved faster than what we do today, right? Because there's a visual representation of what's happening, right? And how that thing interacts with everything else, right? So I'm super excited about using it. It's already helping us troubleshoot problems and getting to solutions faster and getting the right team involved, right? We talked about MTTR before. it's not fact, it's it's not fiction, rather it's fact. Like, that's one of the most important metrics that we have on the ops side. So being able to make it easier and be more organized, I think, is super important for folks on my team, specifically. Right. So excited to see people use it. I'm excited to use it. So, I mean, if you guys have questions, happy to answer them. I think, Paul had a question. Do we want to start doing questions now, or?
Yeah, this is a great time to start the Q&A. If you haven't had a chance yet, you can add any questions you may have into the question manager, which is going to be on the left, or you can just drop it right into the chat. That's fine too. We'll answer them either way. And actually, whilst we're waiting for a few more questions to come in, I'm actually going to share our final poll where we can look at, there we go, thank you. We can open up follow-up questions on what further information would you like to know about Catchpoint. You can obviously ask us now, but if you're in a hurry, feel free to click appropriately, and we will get back to you. So with that said, who'd like to answer Paul's question about does stack map dynamically determine slowness?
You want to take it, Brandon, or you want me to?
Yeah, I can take the first one there. Yeah, so we automatically determine slowness, and I think this is where you're going, Paul. But essentially, what we're doing here, as you can see on each hover, we're pulling out the service time that obviously associates with that specific service within
Brandon.
that.
Hold on 1 second, Brandon. I need to close this poll and stop sharing, so you can reshare your screen.
No worries.
Go ahead. No worries.
Share the screen again. All right, perfect. A little bit of delay there. All right, perfect. So we automatically pull out the service time per service per layer. And what that does is obviously leveraging your existing synthetic test. And as Tony mentioned, that could either be based off IP, sitter, it could be from a DNS resolution for a specific test, or a specific third-party provider or pixel, right, on that individual page. So we will automatically determine slowness for that service and go ahead and apply it to the stack map appropriately.
Yeah, and usually what we do on our side is we baseline things first. So we measure first, right? We decide what our thresholds are, and then we define our own thresholds, right? Like, this is what we think is healthy. This is, this is where we think it's not healthy, right? Or you can auto detect some of that stuff, but I'm still a little old school. I like to kind of threshold on my own and take a baseline and then say, yeah, this is good, this is bad. And then if things start showing up bad and they're not bad, then we obviously modified the threshold. But it's something you can easily do up and set up in Catchpoint tests, right? You can actually do custom metrics too. So one of the other things that we're starting to play with is importing data from other devices, right? So can I pull in my load balancer data, right? So I know if a pool is healthy or not, how many servers are actually in service, right? So it would make it easier to say, like, hey, this service is red, so like in the API pool down below, here's my server pool. This server is actually out of service, so it doesn't matter that it's red. Right? Simple stuff like that. But you can pull in SNMP data. You can pull in, streaming telemetry if you want. It's relatively straightforward to pull in data from other sources.
Thank you, Tony. We have another question here. Do we have auto remediation features included?
So auto remediation is a complex problem, right? So I think right now we leave that to you to make that determination, but like we can feed data back into like NS1 or, other DNS providers that you can, based on the data that we collect for you, you can ask them to push changes, right? Based on that information, right? They have that, like NS1, I know, has a custom prober that you can use on the outside, and that could pull a server out of service or pull a VIP out of service if you wanted to.
just to insert my 2 cents on that one, I was at a Cisco Live trade show not that long ago, where one of the focuses was definitely on AI, and everyone there was talking AI and promoting new AI capabilities. And I asked a lot of the ITOps people, so AI looks really cool. Would you like it to auto remediate? Have a system where the API for the AI system, for example, notices that one of your CDNs is slow and automatically flips onto one of your others if you've got a multi-CDN setup. And every single one of them cringed and went, "We don't want anything automatically changing our network. Thank you, no. Let me know about it, but let me get a human involved." So
it's always the trust. It's the always I don't trust it until I can verify it. So I'm, like I said, I'm a little bit old school in that way too. I kind of agree with that philosophy, right? I would have to see its recommendations for a while before I would actually trust something to go do that for me.
Agreed.
It always sounds great, but it's always tricky.
Another question here. I have found dynamic thresholds to be effective at catching drops in throughput. Most of my old-time monitoring experience did great for high loads, but tended to miss the lower-end thresholds that indicated a loss of connectivity or a failed connection upstream. I'm not sure if that's a comment or a question.
I think it's a little of both. Yeah, there you go. It's mainly a comment, but yeah, I agree with that.
There we go.
Yeah, I mean, but you can set thresholds both directions, right? So like, load times could be a problem also, right? If everything drops to 0 and that doesn't make sense, then you definitely want an alert for that.
Definitely.
But I think that's the area of ML. So I'll call it ML because it's machine learning to me more than AI.
Yep.
Anomaly detection, I think, is like one of the key things, right? That I do sort of trust, right? I want to know when things are acting different than they act normally, right?
I think there's definitely room for automatic remediation or automation if it's a known issue that has a known solution that is consistent and you can trust it.
Yep.
The idea of, for example, if I had 5 CDNs, as I mentioned, and I can relatively harmlessly switch between them if there's an issue, yeah, that's fine. Throw up an error, do it, so that when I see it a few minutes later, we haven't lost money or you haven't had an impact on user experience. But anything more complicated than that, I'd be very, very nervous about just letting an automated system manage my network.
Yep.
And I think we're actually coming up on time. So unless we get another question in the next minute or so, I think we may have to hold off on this. We're about to hit our 45-minute mark, which is really kind of where we'd like to stop anyway, being respectful of your time. I hope this has been useful. I hope people have found this interesting. If you do find that you have additional questions that come to you later, by all means, feel free to reach out. We can always be reached at catchpoint.com, or you can just even email us at hello@catchpoint.com. And otherwise, thank you very much for your time. We appreciate it. This is recorded. If you didn't get a chance to see this, or someone else who would like to see it, it will be available sometime later. I don't want to promise today, but probably sometime tomorrow. And you can always access it through catchpoint.com. So with that said, thank you very much for joining us. I appreciate your time, and we hope to talk to you again in the near future.